Good afternoon all. Now let us discuss about the speech signal processing in mobile communication. See, signals and systems is the major part in electronics and communication engineering that deals with the interpretation of signals, that is information of signals. See, signal means it is a function of one or more independent variable which contains some information is called as a signal. See, without information it can be considered as noise signal. It is of electrical signals, non-electrical signals, etc. It is used in various applications like telecommunications, biomedical engineering applications, military applications, image processing and compression, etc. Right? See, in this speech signal analysis, we are going to discuss about this case study about how the speech signals are interpreted in terms of analog to digital conversion, and this how the steps to be carried out during this quantization in speech signal processing. Let us discuss briefly.
Central challenge of speech signal processing is how can data be processed, transferred, encoded and reconstructed over a limited bandwidth and noise communication channels while maintaining clarity, efficiency and intelligibility. It requires the designing systems that include removes the unwanted errors and interface and compress the signals and it also correct the errors that are introduced in the transmission and reconstruct speech with minimal distortion, and it compress the channels.
Speech behaves as a continuous and analog signal which captures the microphone and later with text. Frequency. Human speech which starts with 300 kHz to 3.4 kHz which stands the telephone band, and next time variability. Speech is non-stationary and unlike it is a constant signal.
The challenges that are faced in signal processing are background noises like street, wind or static interferences, and echoes in enclosed spaces, and bandwidth constraints in telephone channels, and efficient compression without losing its intelligibility.
These signals, we are going to analyze these, how these speech signals can be in terms of modulation. See, modulation is nothing but the process of varying the carrier signal in accordance with the message signal. Right? With the help of this modulation, based on this frequency modulation or phase modulation, we are going to analyze the speech signal processing in some of the signals and systems applications. Here we are using it as here in terms of frequency distribution. We are using the different types of filters like a low pass filter, high pass filter, band pass filter and band reject filter. See, based on this frequencies, we are going to analyze the how signal can be processed in terms of speech, how they can be used in mobile communication.
Signal integration, a microphone converts as a various form logo ports into electric signals. Pre-amplifier boosts the beat signals to beat signal before further process. For example, smartphones MEMS micro electrode mechanical and systems. The smartphones widely used for eye sensing.
High pass filters removes the low frequency and DC accents. Low pass filters limits the signals to the speech band greater than or equal to 3.2 kHz for telephony. High suppression techniques like spectral subtraction and linear filtration is enhanced the clarity. Example, noise cancellation in headphone applies these techniques in real time. Analog to digital conversion. Speech samples are commonly 8 kHz, 116 or higher to the high quality signals. And the partition amplifies the value to the state level. Results the digital representation of the discrete signals. Example, in telephony, the pulse code modulation uses 8-bit or 16-bit modulations.
Next, we are going to see about compression. It reduces the data size without losing the intelligibility. So, for this, we use LDC, which compress the speech into efficiently. So for this, we use two types of system, which are self and advanced forex. Self is used for 2G systems and advanced forex is used for 5G or 4G systems. For example, WhatsApp calls, we use Opus system, which is also called as advanced systems to adapt the bit rates. So next we are going to see about channel coding and transmission. It adds the redundancy to predict the error and also correction. By adding this, we can protect the signal without losing the signals. For this, we use two types of methods, which are convolution and turbo coding. For example, 4G LTE uses turbo coding for without losing the signals.
Yes, reception and reconstruction. The receiver decodes the compressed speeches and applies error correction and reconstructs the signal. Echo cancellation removes delayed version of speeches and delayed version of speeches. For example, Google Meet and Zoom apply real-time acoustic echo.
See, overview, we can remove the unwanted noise signals and interference, and also we can compress the signals compress the signals for transmission for better bandwidth, and also we can correct the errors during transmission, reconstruct the signals for transmission. See, next one is the signal transformation. See, signal transformation by using the ADC signal. See, analog to digital conversion. With the help of sampling these frequencies, we can going to convert the analog signal into digital signal. And then signal acquisition. By using better modulation purpose, the signal acquisition can be easily achieved. And then pre-processing and filtering. See, pre-processing is multi-rate signal processing. With the help of multi-rate signal processing, for using examples, we are using LMS algorithm. By using the pre-processing and multi-rate signal processing, with the help of these processing, we can going to decimate and interpolate the speech signal by using the multi-rate signal processing applications, right?
The speed signal process has a wide range of applications like mobile phone communication, core of 2G, 3G, 4G and 5G voice calls, and voice over PA. Platforms like Skype, Zoom, WhatsApp depend on advanced speech codecs. And next is voice assistants like Siri, Alexa and Google Assistants rely on clear speech recognition for natural language processing, and like hearing aids amplify the signal while filtering the background noise for hearing impacts. And in military communication, secure robust speech transmission in noisy environments.
Finally, we are going to conclude with the help of these transformation methods, we can transform from the time domain to the frequency domain. See, with the help of frequency domain, we are going to analyze. We analyzed the speech signal processing in mobile communication. Finally, we can going to with your analog to digital conversion is the process of from analog to digital conversion, and then compression. See, compression of these signals with the help of these IIR filter or FIR filter design. See, IIR filter design means only we considering infinite samples, and FIR filters means we are considering only the finite samples. By all these applications of channel coding and transmission and then reception, by using different types of algorithms we are using, we can going to retrieve the, we are going to get the final signal processing applications in mobile communication.
Speech signal processing is a multi-process signal and system that enhances the global real communications and real-world time communication. And this case study highlights that the signal and system that provides the not only provides the mathematical base and it also provides the entire technologies like RAM and ROM. And by this technology, without these technology, the real-time world communication is not possible in this time.
Thank you.